With Data Formulator, you can create visualizations beyond your initial dataset. With AI, Data Formulator transforms data based on your natural language prompts and provided examples. The data view shows your original and AI-generated data tables in your workflow. You can create or derive new data concepts from your original data with the help of an AI agent. Then, in the chart builder, you can create charts by encoding data concepts to chart properties. And you can keep track of all your generated charts in the visualization view. To demonstrate Data Formulator, we'll start with this daily temperature dataset already loaded. The dates include all the days in 2020, cities are Seattle and Atlanta, and the temperature is in Fahrenheit for the respective city. This is a long or tidy form dataset. So let's get started by visualizing the data. When all data concepts are known, we drag and drop them onto chart properties and immediately see our chart. This scatter plot shows temperature for both cities over time. Now let's save this chart for reference. Instead of temporal trends, we want to directly compare Seattle and Atlanta temperatures. But we don't have these concepts, so we create new unknown concept for Seattle and provide some examples from the table. We then select example values for the Seattle data concept. And we do the same by creating an Atlanta temp concept and providing examples for this one as well. The examples provide the system with an understanding of the new data table we are trying to generate. We then drag and drop the Seattle and Atlanta temp concepts to visualize them. Formulating generates a new data table from unknown concepts. Data Formulator is trying to construct this new table, but needs us to fill in the example table based on our original dataset. In the new table, each row is for a day. Then after we formulate, the scatter plot of Seattle versus Atlanta temperatures appears, and the formulated data table is in the data view. The table is now in a wide data format. With the data in this format, we can make direct comparisons. So we derive a concept from Seattle and Atlanta temp to compute the difference. We describe the transformation and click to generate candidates. The first choice candidate appears with example differences. We can verify the transformation's correctness as TypeScript code as well. And save it. And we also actually want to derive which city is warmer on each day. So we derive from Atlanta and Seattle again, and write a prompt asking Data Formulator check which city is warmer, Seattle, Atlanta, or if they're actually the same temperature on that day. Clicking Generate, then generates a couple of options for us. Both values for my derived concept look accurate, but I like candidate 2's more verbose description, that one, and save this derived concept. Now let's visualize these concepts of which city is warmer. I'll show warmer as color on the existing scatter plot. The colors are bisected as we'd expect. I want to also show these patterns temporally, so I encode date on the x-axis, and we see which city is warmer and by what magnitude using a bar chart. Also, it'd be interesting to know how many days is one city warmer than the other, so I'll create a histogram of that. And we see Atlanta has about 300 days where it's warmer to Seattle's 50. And let's save that chart. Finally, we want to show Seattle's temperature changes over the year. To smooth out outliers, we derive a 7-day moving average from the Seattle temp data concept. Inspecting our two candidate derived values in code, both look to be computing moving averages, but the window is always right aligned, computing the 7-day average from the last 7 days. Instead, we want to compute a middle-aligned average, so we add to our description starting with 3 days before, ends with 3 days after. And we generate our derived values. Now, the first candidate is actually incorrect, but our second candidate computes the middle-aligned moving average that we wanted. We confirm and save this derived concept, and we can check the 7-day moving average as a histogram. Doesn't seem like we have any erroneous values, so we can move on to create a line chart with date on the x-axis and the 7-day moving average on the y-axis. And we can see that on average, Seattle doesn't deviate outside of mild temperatures throughout the year. Finally, we can recap all of the charts we have created in Data Formulator.